Hello and welcome. My name is Kristin Hunter-Thomson, and I'm from Dataspire Education and Evaluation. And I'll be talking with you today about work we've been doing with elementary through high school teachers throughout the country, helping to bring real-world data and data literacy skills into math curriculum in strategic and collaborative ways to make teaching easier and setting our students up for more success with their math content. Please remember to download the handout for this session from the resource space on the event website. And following the session, I'll be responding to questions live via the chat space for a Q&A. And with that, let's get started. So I am a certified middle school and high school earth and life science teacher. And then, like what happens for most of us, once I got in, I was then asked to teach math. And then a few years later, I was asked to teach social studies. So I have worn many hats, grades 5 through 9, when I was in the classroom. And man, did I love the students that I worked with. But for various reasons, I decided to go on and get my degree in fisheries biology. I got to be on a submersible off the coast of Central California, which was absolutely incredible, except I really enjoy talking with people. And so quickly found my way back into the space of education and was particularly interested in how we can connect students' learning to the real world. And as I was going through, I was doing curriculum development and professional learning. I started to see that many of the teachers I was working with were struggling with the same things I had been struggling with, which was how to help our students engage with the data and make sense of the data. So about 13, 14 years ago, I started pivoting more and more into this data education space of how can we translate research into practice, and how can our classroom practice support research to learn more about how our students are learning? 4 years ago, I pivoted out and started Dataspire. We now run professional learning all over the country. I come at this from a professional space of loving what I do, supporting educators and empowering students, and also selfishly from a personal space of I now have 2 littles in the system. So I can tell you that story with words and with pictures, and I can also tell you that story with data. And more creating data visualizations are available to us, and it's an incredible medium to be able to tell different kinds of stories. So I can tell you the story of my career in a pie chart. I can also tell you the story of the fact that I am a very accident-prone person. I'm going to try not to visit the emergency room while we're here together for this session. But data is really powerful as a way to communicate stories. And that's why I think it's got some great hooks in. So where are we going? We're going to norm set a little bit more about this context for math and data. We're going to explore a bit of why and how leveraging data in all of our math topics can be really beneficial for us and our learners. We'll consider ways to strategically align our efforts so that we can work smarter, not harder. And then we'll identify some next step takeaways. Okay, before we get going and dive into everything, I want us to pause for a second and look at this graph. So some orientation. Along our horizontal x-axis, we have average sugar consumption of grams per person per day. It's increasing as we go to the right. And on our vertical y-axis, we have average number of decayed teeth per person. It increases as we go up. So take a few moments and just look at this. What do you notice? What patterns do you see? How would you interpret what's going on with these data? Okay, got it? I should say, this is not a trick question. This, in fact, is a graph that has been used in peer research studies for a couple of decades now. And the participants, the US adults that participate in the survey, are actually given multiple choice responses. So it's less open-ended than I just gave it for you all today. And it is illuminating to me. Only 50% of respondents whose highest degree is a high school diploma can correctly pick the multiple choice item that identifies that as your sugar consumption increases, your likelihood of having more decayed teeth increases as well. Now, what is some good news is that 84% of respondents who have a postgraduate degree can interpret this graph. Great. My question is, why is that not 100%? But my bigger question is, do we really think it's necessary to have a postgraduate degree to make sense of this graph? And I vehemently believe that the answer is no. This is in our standards. This is in our K-12 content, and setting up our students for success means getting it so that more of adults, regardless of what they've done after the K-12 space, can make sense of these data. Because it builds off this data literacy principle, which can be defined as the ability to collect, organize, visualize, analyze, interpret, and share data for yourself and others to use and understand. That is a big definition. It encompasses a lot of more narrow definitions, and that is on purpose because I think this is really what we were going after in the K-12 space to set our learners up for success in this world. So let's think a little bit more about this math data context. We produce a lot of data. So we are looking at the volume of data, information created, captured, copied, and consumed worldwide that we know of from 2010, so not that long ago, and then projecting out to 2025. And there has been this like whoosh, big increase, and we're projected to just keep increasing it. So there is a copious amount of data. In fact, one might say we live in a datafied society. Data are all around us. Therefore, it's not too surprising that thousands of people across our country are now employed to be data scientists. Their whole job is to make sense of data. But what I find even more interesting is that how many different industries, how many different jobs now use data. So data are all around us, and we know that in the education space. We have some data on our students. So our 2022 National Report Card indicates that overall, our students who took the NAEP tests, we saw a decrease in their overall math scores. Okay, that's interesting. That shows us a trend for all of the students. But what I find really interesting is when we dig into like by content area, what are we seeing? What are the trends by content area? Some quick orientation. Typically, we look at time data of left are older dates, right are newer dates. In this table, it is a bit sort of switched a little bit, where on the left we have 2022 and on the right we have 2019. So as you're looking through these numbers. And so here we can see across all of our content areas, like big buckets, we are seeing decreases. And this data analysis, statistics, and probability, we're also seeing, and up at the 8th grade between 2019 and 2022, we saw a really big drop for our learners. What I also find really interesting, and what really struck me from that report card, and interested to see how this is continuing to go, right? This is our trend. Are we maintaining the trend? Is that where these decreases were coming through. And for our 8th graders, we saw a decrease in this particular content area in all 50 states. Okay, so we've got a lot of data. It's part of our math standards. We're seeing that our students are struggling based on this point in time test that we have that some of our students are taking that indicates a trend. But let's look at some other data. Specifically, let's look at some data from parents and teachers. So this is research from the Global Strategy Group with support from the Bill and Melinda Gates Foundation, in which they asked participants, which of the following best describe what you think K-12 math education should ideally be like? And what I want to call your attention to is that across the board, parents and teachers aligned on making it relevant to the real world. And then useful, focused on creative problem solving and engaging. These were other aspects that were coming up to the surface. And here is where things get really exciting, because all of that data we are producing, the standards that show up in our curriculum, and real world data and real world application collide in data. And that is how we can think about how do we help our learners, yes, build out that data analysis, statistic, and probability skill set, but there are other content areas as well, making it relevant to our students. So let's first think about that kind of how we can use data to teach our content. And I am not Pollyanna. I am not here saying that we can use data in every single one of our math standards. No, not at all. There's some things where it just doesn't make sense. It would be like round peg, square hole. But there are many, 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 many standards in which we can use real world data to help that learning of the content be more real world applicable, be more engaging. So let's think about that. Obviously, the ones that explicitly call out data, the ones that call out real world application and context are great ones to use. The ones that involve modeling and/or expect students to compare parts of a whole or attributes of a population. These are all indicators of standards that might do really well using real world data to teach that math content. So let's use this one, HSF.LE.5, where our students are working to interpret the parameters in a linear or exponential function in terms of a context. So we've got them practicing that exponential function, and then we could jump in and change this up a little bit so the X and the Y actually have labels to them to kind of create that context. It could be a hypothetical context. Or we could use carbon dioxide emissions and have them look at the exponential, or, is this exponential? Is this linear? What kind of functional fit is it? And what does that tell us about time and carbon dioxide emissions? And so in the same content, but using that real world context can be more engaging for our learners. And I think my colleague Colleen put this really well with the analogy of kind of where's the fruit? Our low-hanging fruit, when we're thinking about integrating data into our instruction, are things that we can do as our do now, our bell ringers. Think about 5, 10, 15 minutes. So like Turner's graph of the week. What's going on in this graph? All these links are in the handout. So make sure you download the handout. So this is kind of the low-hanging fruit of how we can start integrating more real-world data into our instruction. And then we can build on that in a progression. We can start using full lessons that are based around data. There are a lot that already exist out there for many, many different math contents. So it can be in most or all of our units, it being real-world data. We can create our own lessons with data. We can have our students collect and analyze data themselves. And this one I've seen to be super powerful because it humanizes data. We take data out of the space of it's cold, objective, formal, kind of black boxy numbers, and we bring it in to the human realm. And this can be really helpful for the self-efficacy of our learners, identifying as I do data, I can do math. And it's true. Data are always created by people and for people, even if AI is generating it. And data are often created about people. So let's leverage that to our advantage. We can ask students a question and they can physically plot their answer to the question, and we can co-construct a graph together. In this way, we can be teaching them about different graph types, but also the representational nature of how a dot or a bar in a frequency bar chart or our histogram represents something in the real world and how that connects in to how we're interpreting it in context. We can even physicalize data by moving our bodies through space. This is a participatory approach to data. And this engages and pulls our learners in. We can also have our students be more creative in how they are representing the data. Now, this totally can align with one of our content standards, or it can be slightly tangential to it. And I advocate, and the teachers that I work with are seeing with their learners, that time off task of opening it up and being a bit more creative as to how the students think about representing the data has a huge return on investment when it comes back to our on-task teaching of our content standards. So creating that space, it opens up the option for students to step into the driver's seat and get really excited about what they're doing. And it's hard to get more real world than kids thinking about, like, our younger students thinking about hair color, right? They see it all the time. It also opens the opportunity for us to think about who is in a data set, who is represented, what is our sample, how do we think about that? And that is key for understanding what we can say from the data. It's also a key stepping stone to having our students explore data using technology, using Google Sheets or an interactive technology, like I'm showing here in a screenshot, not interactive. All the resources to these links, again, are in the handout for the session, but to think about how we're having our students engage with those data. And then we can sort of the top of that progression of this kind of using this analogy of the low hanging to the higher up fruit would be a full data-driven unit. And by data-driven, I mean all of the lessons are around real world data that the students are using to understand that math content or projects with data. Data are for everyone. So I in no way mean to say this is all on your shoulders. Hold that, we're going to come back to it. But truly making sense of data, if we think about how datafied our society is, everyone needs to gain these skills. This is my electricity bill for May of 2019. My electricity company had no problem charging me almost 3 times more in May 2019 as they did in May 2018. This is a double y-axis. We can talk about that in the Q&A. But what you might be a little hard to see is that the temperature was basically exactly the same in 2018 and 2019. I saved money because I could read this graph. So regardless of your career path, STEM or non-STEM, data is a part of our daily lives, and a lot of it shows up in our math classrooms. But it also shows up in our science classrooms and our science standards and our social studies standards. It's in our English language arts classrooms. It's in our music and our art classrooms, and it even shows up in our PE. So what I want to say is that while a lot of the pie of teaching our learners how to make sense of data falls on us in the math curriculum, it is not only on us in the math curriculum to teach our students how to make sense of data, but to make sure we are really setting our students up for success, it requires coordination and collaboration. And a great way to do that is to co-plan and to think about, okay, these are the topics that I'm teaching. These are my upcoming units in pre-calculus. And then talk to your world history teacher, if that aligns grade-wise, and think about, okay, well, what topics are you teaching? Where might you have some data sets? What data sets are you using in world history that I could incorporate in to my pre-calculus course so that I'm getting my content, my math content standards in, and I'm using data that the students are seeing in their other classrooms. That makes it real world. That helps them see the usefulness, which we all see, of our math content, but helps bridge that gap for our learners. This also means that when we have this co-planning time, this coordination time, it's no longer fully on me as the math teacher to go out and find that real world data set that I'm talking about. Instead, I can just walk down the hall and get a data set from a colleague. The students are seeing it twice. I get to use this real world application, increase the engagement on the math content for my learners, and it doesn't require me spending a lot of time to find it. The social studies, English language arts, or science teachers get the benefit of their students are seeing the data when they're in our math classes and working on it from a math perspective, and then they can bring that into their other classrooms as well. which is why we need to strategically align our efforts around this. So one area to do that is around the terms that we use, the graphics we're using, and in my rainbows and unicorns world would be the timing. And I understand that that's not reality now, but it's good to dream of where we're headed, of just let's think about the terms. What terms are we using? So this is work that I did with one district. It was the 5th and 6th grade math and science teachers. We were all together, and it very quickly became apparent that in kindergarten through 5th grade, we called this graphic a line plot in our math curriculum. And in 6th grade, we called this graphic in our math curriculum a dot plot. So even within a department, but across grade bands, we have different terminology. So then think about across all of our grade bands and our different disciplines. So doing a bit of norm setting on what our terms can be really helpful of helping us get a better sense of what our learners are learning and our learners moving through this progression, K-2. Because this really is a progression, and working with data is a process. Anytime we work with data, we get the data, we explore it, we infer meaning from it. But the key thing for our learners is them recognizing that they need to actively be engaged in that middle piece. They're the puzzle piece that holds it all together. Not you as their instructor, as their teacher, but them is that middle piece. In each of those realms, there are different functions, different things that we do. And this is where I really want to call out. This is not only on us as math teachers. This is why we need to broaden it out. Think K-12 and think across our disciplines, supporting our learners building this out. And while we talk about it in a linear way, we don't actually work with data in a linear process. There are multiple entry points in. And thinking about this, how do we make this a progression? Well, let's look to soccer. It's a really big thing here in the United States. When my children were in kindergarten, I signed them up for town soccer. My town calls it soccer. I call it amoeba ball. I know where the ball is because all the players are around that ball. That looks really different than our women's team that just represented us at the World Cup. But here's the great thing. We are not working to create professional World Cup soccer players or professional data scientists. What we are doing in the K-12 space is thinking about how do we set our learners up for that next step, workforce, 2-year, 4-year, wherever they're going after the K-12 sequence. And this is where we can take a nod from the playbook of soccer and sequence it out and help our learners work with data every step of the way. Yes, to learn those data skills, but also to learn our other content so that the complexity and the nuance can build over time and create opportunities for our learners to practice. So a colleague and I built out a resource where we use our math content standards, but as well as our science standards, our social studies standards, and the past couple of decades of research about how kids learn from data to build out a sequence, K-12, of how students learn from data, how that progresses as we go through that learning progression. But almost, if not more importantly, we love using this resource to get a sense of kind of what's our lane. As a 6th grade teacher, what is my job? What's my piece of this progression to help my learners with? What are my colleagues doing before me? Before the learners come to me, what will my colleagues do with these learners once these learners leave my classroom? And thinking about piecing all of those pieces together. And we've built this out as a building blocks because while our field should not be additive, we should not have more and more and more and more added on to our requests for what we do. This is actually additive. We learn a set of skills and then we can build on it, more complex sets of skills or the next complex step for that. And then we master that row and then we build on it. And this concept, this building blocks, is a really important mindset for thinking about data literacy because we can get students to execute and follow through on a task in our classroom on a certain level of skill, but they're not retaining it to then be able to apply it independently after the fact, like on state tests or NAEP tests. And this might be an indication that they're missing this lower tier building block as they're going through. So when we work with teachers with this resource, we helped them to think about, okay, what's a new area or an area you're going to focus on in a new way? And what will you take out or what will you put into the background? Because again, there are only so many minutes in the day and only so many days in the school year. So how can we think about what we're foregrounding, what we're backgrounding, and then how are we being strategic to collaborate with our colleagues to make sure through this full progression, our students are picking up all of these skills and content areas. And this can be done within a department or across departments to sort of coordinate our approach of who's taking lead on what to make sure we're all rowing in the same direction, but each of our loads is possible and feels manageable. It can identify some great things of coordination of we're seeing in math and science that our students struggle with interpretation, but we feel it's really important to keep, or we see our students struggle with independent and dependent variables. Math thinks it's really important to keep, and science is wondering if we can drop it. These are great conversation starters. I do want to say what we have found as we do this work across departments is that sometimes we use the same word to mean different things, or sometimes we use different words to mean the same thing. And getting that clarity within schools, within the building, within schools, within districts can be really beneficial for us as the facilitators of learning, but also for our students. It also creates spaces in this coordination to think about the sort of softer skills or the instructional approaches or strategies that we're using and do coordination across those. And so really what we're getting at is this more kind of holistic, can we bring in our content and real world application using data, teaching these 21st century skills in coordinated and aligned ways so that we can all work smarter, not harder, in helping prepare our students for their lives ahead. A few final notes to consider. It's been a lot of me talking, so time for you to do some thinking and looking. So 4 data sets, 1, 2, 3, 4. They each have the same x-axis, 0 to 20 in increments of 5. And they all have the same y-axis of 0 to 14 in increments of 2. Are they all the same? Are they all different? Are there any similarities? What are the differences? Are there differences across these? Would it surprise you to know that all 4 of these data sets have the same summary statistics? And knowing that, now what do we see when we look at these data? I fit a linear function to all of them. We could certainly discuss why a linear function is probably not the right fit for those data. But this is just to say, this is an example of we need to look at things from multiple angles. We need to approach things from multiple different perspectives to help us better facilitate our learners and to help our learners gain these skills, to set our learners up for success. And I just think Datasaurus is really fun. Who doesn't like a T-Rex? This is another set of data sets that Alberto Cairo put together representing that same phenomenon. So I know you're really busy. I was in the classroom. Everyone at Dataspire was in the classroom before, but there are some round wheels out there that we love getting out there to make it just a little bit easier, make it sometimes a little less like you need to use the square wheel as you're going through. So the takeaways. Look for opportunities to incorporate more data throughout your curriculum. Check out the resources that I've linked in the session handout as a great place to start to find some options for those opportunities. And leverage your colleagues to your advantage and your students' advantage when teaching your math concepts with data. So we can make it real world relevant, we can make it engaging for our learners, and we can teach all of our content to try to help set our students up for more success going into the future. You've got this. We've got this. We're all in it together. I look forward to answering your questions soon. But before we get there, I just want to leave you with this quote by Dr. Martin Luther King Jr. You don't have to see the whole staircase. Just take the first step. It can feel like there's a lot coming at us that we need to do for our learners, but just take that first step on thinking about how to incorporate more real-world data into what you do. I look forward to answering your questions. Thank you for your time. Thank you for joining. There's some great conversations happening in terms of cross-disciplinary work with middle school and high school and things like that. Excellent. There's some questions of, have others found the resources about for this session, which is a great question. And I don't actually know the answer to that question. I thought it was going to be popping up for the session, but I think instead what it is if you're looking in the interface along the left-hand side is the menu of lobby attendees, announcements, agenda. And at the very bottom, there is a resource tab. And so hopefully in there, you can find the resources for the session. Phil, I've added those 2 links that you dropped in the chat during the session into that Google document. So that is there. If others have some resources that we can use as a community to pull together for ideas about cross-disciplinary work, please share them out and I'll add those into the Google document as well. The name of the resource is Using Data Literacy Building Blocks, September 19 to 23 Math Summit Resource. Apologies if that was confusing. Excellent. So one of the things that we have had a lot of success with that I was talking about in this session is pulling people into the same room and creating space and opportunity for that co-planning. It is such a critical opportunity for teachers to have that time together, to have those aha moments of we're teaching really similar things, or there's great opportunities for synergy and overlap on a project-based unit, or just on, I'm teaching math and I need a data set and would love for it to be real world, but I don't have the time to find it. Great, let's walk in and with a real world data set that we're using in our social studies or science classrooms. So that has been really helpful. Creating that shared time has been really helpful in our experience with the middle schools and high schools that we are working with. Another great opportunity is coming with our scope and sequence, our curriculum. We often do this in summer work where we're pulling folks from different departments together, but we had some great opportunities at the end of the last school year to do some forward planning for this school year across high school math and science departments, as well as math and social studies departments. It's always fun. Everybody comes in and they're like, why are you making me talk to social studies? Why are you making me talk to English language arts? And then 20 minutes later, walk away with like, there's so many different ways that we can coordinate and that we can make things easier for each of us by distributing out the load, making it feel like we're all rowing in the same direction. Excellent. So we have been working on, I see a question of what schools and districts have we been working in. So we've been working in a variety of different schools and districts. That work I was just describing that we did at the end of last year was with a New Jersey district, Fairlawn Public Schools, but we did work all throughout last year. We actually did a year-long program with middle school and high school math and science departments at the Bend Lapine School District in Oregon. We are kicking off work, actually kicked it off yesterday. I was in Ohio, super exciting, in Liberty Township, Ohio. That's a K-8, so we're bringing this work down into the K-8 level. We've done work across science and math in some of the Texas districts that we work with. There's another in Virginia. We were in Virginia coordinating between science and math departments there. Yes, that benefit of forward planning. Excellent, excellent. Wonderful. So you all are also doing amazing work. Would love to hear about work that you're doing. Please share it in the chat so that we can share it out. We can capture it in that resource document. I think one of the biggest things that I can share, given that we take it from the approach of how do we support teachers, how do we translate the great work that Phil and Andy and others are doing, Holly Lynn and everyone out there, and translate that into practice and create those opportunities, those shared spaces, so that our teachers K through 12, we work K through 12, can walk away with feeling, oh, I've got a sense of what my piece is and how my piece fits into the bigger puzzle. And helping to illuminate that, that's really where we lean into the building blocks document of, okay, what is my space? How are we working there? How does that fit into the broader connections of what my colleagues are doing? And so oftentimes, as much as possible, we try to be cross grade bands so that we can foster those conversations, as well as, or in a, in exchange, cross disciplines, because this isn't anything that any one of us can do in one lesson, one unit, or 1 year. This, I truly believe, helping our students become data literate and helping our students gain these data analysis skills that are showing up in our math standards requires connection and integration into how they're using data as required by the standards in their science curriculum or as required by the standards in their social studies curriculum. So creating space, but then also providing resources and facilitation of that co-planning space has been what's been really helpful for us as we have been working with different schools. Excellent. Josephine sharing out some other great resources. We will drop those, we'll make sure those land in the resource document for today. If you miss it and don't get to catch it in this chat as we're going through, but definitely make sure you click on that to get into there. And so we are almost at about time. I thank you for joining us. I thank you for sharing out all these great resources. Keep them coming. My contact information is at the top of the resource document for today. Again, using data literacy building blocks, really thinking how can we build and how can we build smarter, not harder. So we're all working together and we're really leveraging the space that we have across within our buildings, across our disciplines to support our learners as they're building these fundamental math skills, and so they can apply them across our other disciplines. So thank you so much. I hope you enjoyed the rest of the conference and the summit, and I look forward to connecting with you all soon. Thank you.